All right, good morning. This video, if you're watching this, this is if you were out, you probably, well, what we were doing in class on Wednesday, which is today, is we're looking at the 611, the task. We're looking at questions 5, 6, and 7. And in class, you had to work on those three. That was it for today. You had to draw the situation, the scenario, and you had to answer the following question. This literally should take less than 5 minutes. All right. If you stop and focus, it should take you less than 5 minutes. A lot of students, it's going to take a long time because you want to sit and you have a class, right? But based on the situation, it says we have a plane that's 2,000 feet in the air. It's wanting to land at a 7-degree angle of depression, and it wants to know how far it is from the airport. So what we look at is we look at, hey, here's the angle of depression. And we have to be able to obviously use a trig function to be able to find this. I know an angle. Well, look at the situation you've created. Obviously, this is the 90-degree angle, angle 1 there. I don't know any of the other angles inside the triangle, or do I? And I know that the plane is 2,000 feet in the air. Well, again, look at what we know. If we look at this, and the reason I drew this dashed line here, which maybe you didn't draw, but the reason why I did that is because angles of depression and angles of elevation are the same. We get this whole parallel line cut by a transversal thing going on, and we get alternate interiors. So the angle down here inside the triangle is 7 degrees. This would be the angle of elevation looking up. They kind of go hand in hand. We talked about that before, so you have to recognize that. So now I do know an angle inside the triangle. In the context of the problem, I know a leg and I want to know the other leg. So the way to solve this is by the tangent. So the tangent of 7 degrees is equivalent to leg opposite, which is 2,000 over leg adjacent. And you can go ahead and solve from there. Make sure you show your work. All right, I'm going to skip the step there, but make sure you show that. This should be reasonable. It should be longer than 2,000 feet. Which it's actually really long, and I want the answer in miles. All right, so answer in miles. So how do I answer in miles? Well, you're going to get a certain number of feet, and you're going to divide that. Come on, seniors, you should know this, 5,280, and that's going to tell you you should get approximately 3 miles. All right, I'm not going to tell you what that number is, but go ahead and write that in there. I'm going to be looking for that when I grade your work. Okay. Second one, number 6. Okay, you have a building. Michelle is 60 feet away from a building, obviously 60 feet. The angle of elevation at the top of the building is 41 degrees, pretty self-explanatory. How tall is the building? Well, again, in the context of the problem, what are we dealing with? We're dealing with 60 feet, which is a leg. We're dealing with the height of the building, which is a leg. And the only trig function that works for that is the tangent function. The tangent of 41, which I know the degree angle, is related to leg opposite over leg adjacent, which is 60. It's cross multiply, it's a one and done. All right, in your calculator, it spits out what the answer is. Okay, and the building, it's just over, and I'm going to say, well, let's go back and you be the judge, all right? If this is my 90-degree angle and this is 41, obviously the longest side is the hypotenuse. So which leg should be longer? Should it be 60 feet or should it be X? That's based on this angle up here. So 90 minus 41. What is 90 minus 41? (49 degrees, right? If this angle is 49 degrees, that means this leg is longer than this one. So your answer should be less than what? X. X should be less than 60 feet, sorry. Is what it should be. The closer these angle measures are, the closer the legs are in length. And then the last one, I should give you a grade based on your arts and crafts ability here. Here's the scenario you should have drawn for the last one. Notice I got the ship, I got the boat ramp, all right? This one gets a little bit tricky because it's asking what is the angle of elevation of the ramp, because obviously you're going from the dock to the ship, right? This is over exaggerated, of course, but I'm looking for an angle. In the context of the problem, what do I know? I know a leg, and I know a leg opposite. I'll just write leg OPP, and I know the hypotenuse. That right there should tell me it's sine or cosine. So I'm going to use the sine and cosine of an angle, and I'm going to create leg opposite, which is 6, over hypotenuse, which is 10. Opposite over hypotenuse is a sine function. Now, where's my variable? My variable is here, so I got to get rid of the trig function. How do I get rid of the trig function? Okay, it's, again, go back to 3x equals 15. How do I get rid of 3? You divide by 3. Yes, you do the opposite of what is there. So in order to get rid of that trig function, I have to do the opposite of what is there. Right? All this is learning how to do the notation. You should know by now how to do the notation. All right? X is equal to the sine inverse of 6 divided by 10. Right? And X is going to be approximately, and if you look in here, X is approximately, I put my answer in feet, which is ridiculous because it's 36.86 or 36.9. Even if you put 37 degrees, that would be reasonable. All right, so there you go. There's the last of the scenario. That's what we did in class on Wednesday. And there you go.